Okay, so for this problem, we're once again going to use a separation of variables technique to solve the differential equation. And again, first step is to always identify the dependent and independent variable. And once again, dependent is y because it has the prime on it, and the x is the independent. So now let's go through and rewrite this as y times dy dx plus x is equal to 0. And the first step in separating variables is to subtract x from both sides. So y dy dx is equal to a negative x. And then, of course, multiplying both sides by dx, we end up with our variables separated. We have a y dy is equal to negative x dx. All right, and now we can integrate both sides of this. And in doing so, we end up with 1/2 y squared is equal to negative 1/2 x squared plus a constant c. And oftentimes we can go through and multiply these equations through to cancel out some of the fractions or just redundant negative numbers. So let's go through and multiply both sides of the equation by 2. All right, and in doing so, we end up with just plain y squared is equal to negative x squared. And if you multiply an arbitrary constant times 2, it's still an arbitrary constant. So that's going to stay a plus c. And then from here, you may not recognize this, but this is actually x squared plus y squared is equal to c. And for positive values of c, this is actually going to be a circle with radius square root c. So let's go through now and solve the initial value problem. If we actually take our y value of negative 2, and substitute in 0 for x. Again, this is the value of x in the parentheses, and that, of course, is our y, which is over here as well. Then we're going to have where'd it go? We're going to have our x, which is 0 squared, plus our negative 2 squared is equal to c, and that forces c to be equal to 4. So our solution is going to be x squared plus y squared is equal to 4. And that is the implicitly defined solution. And if you graph that, you'll recall from algebra or trigonometry or pre-calc that this is a circle. It's a circle of radius 2. And if you think about a circle of radius 2, it has some issues being the solution of a differential equation because we can't have tangent lines that are vertical because they have an infinite or undefined slope. So we have to either pick the top half of the circle or the bottom half of the circle to be our solution. And we notice that we have negative 2 as the y value, so that makes our solution the bottom half of the circle. So to actually sketch our solution, it's going to be the bottom half of a circle of radius 2, and it's going to have open circles at the end because we can't have derivatives at those locations. So the interval of existence is going to be from negative 2 to 2. And again, excluding endpoints. And if you wanted an explicit solution, you could algebraically solve for y by subtracting x squared from both sides, and then taking square roots of both sides with a plus or minus, and then our y of x would be negative square root of 4 minus x squared. And again, you will notice that if you substitute in a value of 0 for x, you will get a negative 2 for the solution. So that is the solution of that initial value problem.